You ever wonder what's actually going on inside an examiner's head when they're marking your paper? Well, today, we're going to pull back the curtain. We're going to deconstruct a real GCSE chemistry question, and I'll show you how to think just like a marker so you can lock in every single mark. Let's jump in.
You know, it's not always just about what you know, right? It's about how you say it. Getting those top marks, that's all about communicating your knowledge with absolute precision. And in this explainer, that's exactly what we're going to break down.
All right, so here's the setup, pulled straight from question 9 of an AQA paper. It's a pretty classic experiment, right? A neutralization reaction where we're measuring the temperature change. The experiment itself seems simple, but the questions that follow, they demand some serious precision.
Okay, first up, let's talk about the equipment. Now, this might look like a simple question, but these first couple of marks are so important for building confidence right at the start. They're testing your grasp of experimental design, so let's see exactly what the mark scheme is looking for.
And here it is. 2 marks, just for explaining why you'd use a polystyrene cup. So what are the 2 exact points the examiner needs to see on your paper to give you full credit?
The first mark, it all comes down to a single critical keyword. You have to state that polystyrene is a good thermal insulator. Why? Because that word instantly tells the examiner that you understand the basic principles of heat transfer. Using insulator, or the flip side, poor conductor, nails it. See the precision there? Adding the word thermal is even better.
All right, now for the second mark. This is what I call the so what factor. It's the consequence of your first point. It's not enough to just say it's an insulator. You've got to connect the dots and explain why that matters. You have to spell it out. Using an insulator reduces heat loss to the surroundings. That's what ensures your temperature reading is as accurate as it can be.
Next up, the graph. So the student's done the experiment, they've got their data, and now it's time to plot it. This is a chunky 4-mark question, so every little detail is going to count. This isn't just about playing connect the dots, it's a very precise procedure. Let's break it down.
Now check this out. This is where it gets really interesting. You get a full 2 marks. That's half the points for this section just for plotting the 6 points correctly. That is a huge win for just being careful. Then you get a mark for your first line of best fit and another for the second line of best fit. And that final crucial mark, it's for extrapolation. That's just a fancy word for extending your lines past the data points until they cross each other. That intersection point is absolutely vital for what's coming next.
So you've drawn this beautiful, perfect graph. Now what? What was the whole point of all that work? Well, it was to let you find the answers for the next 2 questions with real accuracy. Let's see how that brilliant graph gives us the results we need.
The first question wants the volume of acid right at that magic moment of neutralization. This is the peak of the reaction, the point where the most heat was produced. And on your graph, it's the X value of that intersection point you just drew.
And if you've drawn your graph right, you'll see the answer is 11 cubic centimeters. But, and this is super important, look at the examiner's note. There's a tolerance range. As long as your answer is somewhere between 10.75 and 11.25, you get the mark. This is exactly why drawing those lines of best fit with care really pays off.
Okay, next up, the overall temperature change. Now, this is where your extrapolation work really shines. You might be tempted to just grab the highest temperature from the table, right? But you can't do that, because by the time that measurement was taken, the cup was already losing heat. You need to find the theoretical maximum temperature, as if no heat had escaped at all.
So here's the key. You have to use the Y value from the point where your lines crossed, your extrapolated point. That's your true maximum temperature, 27.5 degrees Celsius. Subtract the starting temp, 18.9, and you've got your answer, 8.6 degrees. And look, once again, there's that little bit of wiggle room from the examiner. Anything between 8.5 and 8.7 gets you the point.
And now for the big one, the 6-mark calculation. I know, this is the part that can make people a little nervous, but really, it's just a sequence of logical steps. If you show you're working out nice and clearly, you can scoop up marks at every single stage, even if you make a little slip-up somewhere down the line.
All right, deep breath. We're going to tackle this one step at a time. First, just calculate the moles of the sulfuric acid. Simple enough. Now, step 2, and this one is so important. Use the mole ratio from the balanced equation, it's 2:1, to find the moles of potassium hydroxide. Okay, step 3, take those moles and work out the concentration of the KOH. See? We're already over halfway there. Step 4 is just grabbing the relative formula mass of KOH from the periodic table. And for the final step, you just convert that concentration into grams per decimeter cubed. Your final answer is 34.7. Each step, a potential mark in the bag.
Okay, and you absolutely need to see this. This is a heads up straight from the examiner's notes. If you get that mole ratio wrong back in step 2, and believe me, it's a super common mistake, the absolute maximum you can get for this entire 6-mark question is 3. It just goes to show how one little slip-up on a core concept can cost you big time. So why double-checking is so important.
So, there we have it. We've taken that entire question apart, piece by piece. So what's the big takeaway here? What does it mean to really think like an examiner? Well, it all boils down to 3 things: precision, procedure, and proving your work.
Let's boil it all down. What do you need to remember? First, be precise with your words. Use the exact scientific keywords like insulator that they're looking for. Second, be meticulous. Follow procedures like plotting graphs and extrapolating with care. Third, show your work. Lay out every single step of your calculations. And finally, always double-check those little details that are so easy to miss, like the mole ratio and the final units. This is how you go from a good answer to a perfect one.
And look, this way of thinking, it's not just a chemistry thing. It's a way of understanding the hidden structure of a question and the logic of how it's marked. So I'll leave you with this thought. Where are you going to use this deconstruction method next? Think about it. Physics, biology, even geography. The principles are exactly the same, and mastering them is the key to unlocking your full potential.